Can you see the screen, please? Can it be confirmed?
Yes, sir.
Okay. Let's start. I believe I started the recording. Just wanted to confirm. Yes, we are recording. That's fine. Yesterday, we looked at how to deal with complex numbers. And I took a simple example of factors of 2. So even though in real numbers, we don't have factors of 2, but here I can basically integers. Here we have factors of 2 in complex. We multiply the two factors and we get the answers. And we have seen that we implement complex number via the library header file called tgmath, which stands for type generic mathematics macros. So if you do that, you've taken care of math.h math library as well as the complex number. Depending on the system, whether OS or Mac, sometimes they ask you to specify the type, whether it's a double complex or a float complex. So it's better to be safe for say double complex, even though here I'd said only complex here. And then I'm just simply putting a number. I stands for, as I said, imaginary part, which is square root minus 1. And that is given by the macro in this tgma.file. And after that, you can do all multiplication divisions based by the number as we are seeing, and multiply factor 1 by factor 2. It actually does complex multiplication. So if I were to multiply, if we look at, if I multiply two numbers such as A plus IB into C plus ID, the answer would be AC minus BD plus iota AD plus BC. So this multiplication is automatically taken care of by when you include the complex numbers. Now, given that we have support for complex number implementations, let's revisit of how do we compute roots of our quadratic equation. So our equation was ax square plus bx plus c is equal to 0. And we know the roots are given by minus b plus the square root of b square minus 4ac whole thing by 2a. And we get a complex number if b square is less than 4ac, and otherwise we get a real number. So we take 3 arguments from command line. We like to deal with decimal numbers, so rather than saying integers, we like to take a double or a float here. So 3 coefficients A, B, and C. You can read either using scanf or you can use using command line arguments. This is my preferred way, but both are fine. And when I discuss the input-output operations, then I go into details of scanf and what are the precautions you need to take care and where you might get into the errors, especially when you're dealing with scanf. So first thing we do is check if discriminant is positive. The discriminant is b square minus 4ac. So this is my discriminant. If this is greater than or equal to 0, we basically know we only get the real roots. So I can compute my root minus b plus square root discriminant by 2a, and same is here. And then I can display root 1, root 2, because I have only real roots. I can display both, and that should work fine. We know that if b square is equal to 4ac, then we should basically be putting only one root, and that we need to make a check. So first it should be discriminant greater than 0. then we should see equal to 0, and this being a real number, we shouldn't be doing plain equal to. We should typecast discriminant as integer type, then we can compare with 0 and print only one root. However, if the discriminant is less than 0, that becomes my else part, and when I get the else part, we'll basically compute 2 square root as minus b plus imaginary, because my discriminant is negative square root, so I need to use a positive value inside. So I'm saying square root of minus discriminant, that becomes 4ac minus b square, and I put in a factor I, making an imaginary part, whole thing divided by 2a. And I said yesterday, this 2a should be in brackets, otherwise the fact would be divide by 2, but multiply whole thing by a, which might give you a wrong answer. So for one factor, one root, we get plus, other is minus I, and complex numbers, they always come in conjugate pairs. And now once we got these complex roots, how do we print? So complex number, you need to print both real part and imaginary part. And we have the two macros called C real and C imaginary. If we look at here, I think again I should have, this should be root 2. This should. So I got my root 1, I got my root 2, and then to print root 1, I first take the real part of the root 1, then I take imaginary part and put an I, and I know that first part is plus, and by default plus is not output when you do printf, so I'm specifically putting plus sign there. And how to get the real part, which is minus b by 2a, I'll get C real of the R1. These are the macros given by tgmat.h. So this gives me the real part. This gives me the imaginary part. And same thing I need to do for root 2. Now root 2, I know that second part, imaginary part, is negative. And by default, when you print any number, if it is negative, the printf automatically puts minus. Hence, I'm not putting any minus sign or plus sign here, because minus automatically will come in. And then you print the numbers. And this is what the program would basically would be. And the program would be over. So just to give you complete code, I uploaded the code. This gives you the complete code. I take 3 arguments, and I'm saying double. If discriminant is greater than 0, I'm defining R1 and R2, putting it. Else I'm doing, if it is 0, I'm typecasting discriminant to integer, because I should be comparing with real numbers, and then I'm printing only one root. Else I'm putting a complex number, double complex R1, and then running this so, and that's how I will get my real answers. Just to show you how the program would run, either I can run through so you can compile this program. I have given this. This is a program which I've shown you. I'll compile and run it. I talked about this comparison running phases in the early lectures. Let's say my program is roots. Program should compile, and once it compiles links, I should be able to run this program, and then I would get my answers. Now I can say C roots. Let's say 1, 1, 1. This means I'm running x squared plus x plus 1 is equal to 0. when I say x squared plus x plus 1 is equal to 0, it will give me imaginary roots, and I'll get the complex answers. So you can see as well, minus b 0.5, and if I were to give you with negative number, the first part would become plus, and you can see that I'm putting plus and minus, and this is the I part, imaginary part. So that's how you can deal with complex numbers. Any question with complex numbers before I move on to the next example? And when any questions, let me know, otherwise I'll proceed. The program is uploaded in Teams program section. You can see it there, run it yourself. And if so, if there are no questions, I'll move on to the next example. Next example is computing binomial coefficient. You know, the binomial coefficient is defined by Ncr, which is factorial n divided by factorial r into factorial n minus r. Sorry, there's error there in this notation, so I need to correct that. So I compute factorial r multiplied by factorial n minus r, and this multiplication is divided into factorial n, and that gives me the coefficient of binomial coefficient of Ncr, which is same as we say, if you were to expand the expression, we know that if I were to do my binomial expansion, a plus b power n, is basically nc0 a power n plus nc1 a power n minus 1 b power 1 nc2 a power n minus 2 b square plus plus plus, and last term would be ncn b power n, which basically means a power 0 here. And these terms are called binomial coefficient. And our purpose is to compute this binomial coefficient. And that is what we want to do, to write a program to compute this example. So one way to do that is, that means I should write a loop that would compute factorial n, then I should compute factorial r, then I should compute factorial n minus r, and that will give the answer. So first approach is compute 3 factorials and solve them. We haven't defined the functions yet, so only using looping, how do we do that? And second approach, we look at more efficient way, rather than computing all factorial, can we be doing more efficient? And that approach will look at direct mathematical expression. And third is called recursion. When we deal with recursion, we will come to that and computing this NCR. So if we look at NCR, binomial coefficient NCR, this is also same as n into n minus 1. Again, I think I have a typo error here. This would be n minus 1. So this approach, n into n minus 1 into, and this would be again a parenthesis here, n minus r plus 1 divided by 1 into 2 into 3 up to r. So we are doing less number of multiplications here. In the first approach, we are doing a lot more multiplications. So let's look at the program both ways. First doing the first part, and then we do the second part. So let's look at the first approach. So we will be given as two inputs. One is the value of R, one is the value of N. So we'll get two command and arguments, and again, you want to use scanf, that's fine. And positive integer should be fine because we can't compute factorial for the negative numbers. So declare N and R as unsigned integers, expect them, and then we have to compute. In this first approach, we first need to compute factorial N, we need to compute factorial R, and we also need to compute factorial N minus R using our loop. Now in this case, if you look at, we know that we have to do N multiplications. In this case, we have to do R multiplications. In this case, we have to do N minus R multiplications. Since number of multiplications are known, it is preferred that we use a for loop rather than the while loop. So we define three terms. One is called factorial N, factorial R, factorial NR, and finally the result that you like to. Since you are doing binomial, your result would always be an integer and not a fractional decimal, and that's why declaring the int result. Ideally speaking, they should be unsigned int and not int. So in reality, you should be using them unsigned int, and so on, so forth. Therefore, you should be using them signed and unsigned int, and use them. And let's look at how do you go about. So how do you compute factorial N? We initialize the answers to 1, run in a loop, factorial int I is equal to 1, I less than equal to n, increment then, and multiply this with I. So this will give me 1 into 2 into 3 into 4 into up to n, and this basically gives me factorial N. I have not put a curly braces here, which I recommend only so that I can show in the same screen. It will take one extra line, space will not be available. So only for brevity, I haven't put the curly braces. And since single computation, that will work fine. But when you write a real program, you should always put these things in a block rather than putting something. So this gives you factorial N. How would you compute factorial R? If I want to compute factorial R, what the loop would be? Any thoughts?
I is 1, I is less than R, I plus plus again.
Yeah, so
Just
the
substituting
only
in with
change we
R.
need to make is substitute N with R, and here instead of factorial N, we'll write factorial R. That gives me, I'll get factorial R. I need to initialize with 1 because that what multiply with remain the same. And same way, if I need to compute factorial N minus R, let's replace this by N minus R and replace this by factorial NR. I'll get that. And now my result I get it, divide factorial N by factorial R and factorial NR. And that is what would happen. And then you print the result and you should be fine. So you got the result, you should printf, and we'll get the answers. Any doubts, questions about this part?
No,
Now, if
sir.
you notice, yeah, this program would work for certain value, but if I'm trying to compute, let's say, binomial 50, 5, this may not work. Because the moment I compute my factorial N, if the value becomes more than 32, it will overflow and you may not get the right answers. So in a real writing program, you have to make sure that when you do the computation, you should never overflow. Otherwise, it will work for to certain numbers, and beyond that, it won't work. You'll get some wrong answers. And that is what we really do not want. So technically speaking, if I were to do, let's say, factorial 50, 1, my answer should be 50, but I don't know if I'll get that answer or something else, because there'll be a lot more overflow and things will become bad. Let's see if I can run this program, and then we look at binomial. So this is the program which I'm doing with computing factorials. So let me run that. I'll compile this. Again, this program is available in the Teams program directory. Let's say 10, 1, it will give me answer 10. If I say 20, 1, see what is happening, you are getting minus 90. Because at certain point, you'll see overflow occurring. For you to figure out at what point overflow occurs, so your limitation that we need to check when things will happen. Even for 15, I should get 15, so my overflow occurs very quickly after certain numbers. 11 is fine. I haven't tested. Some point in time, my overflow would occur. So overflow occurs when 30. So that means my given system, I simply cannot compute factorials with this and I'll get a wrong answers. So that's called overflow. When you write a program, you have to make sure you take care of those overflows. We'll discuss that more in detail, probably time permitting towards the end. But right now, so deal with small numbers and see how to binomial works. Let's look at now the second approach of the binomial. We have the same thing. So rather than computing 3 factorials, we know that my numerator would be n into n minus 1 into n minus 2 up to n minus r plus 1. And my denominator would be 1 into 2 into 3 into 4 up to r. So both my numerator and denominator has r terms. Both my numerator and denominator has r terms. I know the number of terms, so that means I should run a for loop with number of terms being r. And that is what I should precisely be doing. Look at, I'm running a loop so that my loop is iterating r times, starting with 1 less than equal to r. So my loops would be running r times, no more, no less. I know the fixed times. And now I have to work out on computing numerator, computing denominator, and so my denominator is I have to multiply 1 into 2 into 3. So my denominator is, if you look at denominator, 1 into 2 into 3 up to r. So this, I keep increasing by 1 to r, denominator is much easier. My numerator is n into n minus 1 into n minus 2 into n minus r plus 1. Now so if you look at when I is 1, I should multiply n. If I is 2, I should multiply by n minus 1. If I is 3, I should multiply by n minus 2. So that means whatever the value of I is, I should multiply with n minus 1. So essentially, I should multiply, take a term, n minus I minus 1. That is what I should actually be multiplying, which basically gives me, since I'm doing here, so this becomes n minus I plus 1. And that's precisely what we are doing in the program. The denominator multiply I, numerator. So first term I is 1, this becomes n. Second term I becomes 2, this becomes n minus 1, so on and so forth. Now you got a denominator, now you got a numerator, and you should become much better. You should be able to get the answer. And once you divide, I'll get the answer, and that will give the answer. Now that, since I'm not doing whole factorial, I'll probably able to do a little better. Last time when we run, we could got an overflow at the 13. Now maybe able to run for 15, 18. But anyway, some point in time, this numerator certainly give me overflow, and then you have to be careful there. Where do you really want to go? So let's say if I can do that, I'll do, let's say I'll compile this again. To, let's say 21, I should get answer 20 here. So if I were to even give 101, I'll get the answer because there is no overflow happening. But however, if I were to give you 110 over 50, then overflow would occur and I'll get some wrong answers. One has to be careful. How do you do that? We discussed two approaches of binomial coefficient, computational binomial coefficient. So we discussed, first example was finding roots of a quadratic equation involving complex numbers. Second example is computing binomial coefficient, and either approach would work for. Any questions about this binomial computation?
No, sir.
We'll take the third example. All these examples are part of your course. So I'm taking these examples are part of your course, and then probably after when we discuss this, then we look at some other examples so that that helps you understand how we can make use of looping. So essentially what we have done in the complex roots, we have taken an if condition and we have taken the looping there as well. Here is only looping. Now let's look at third case, something called displaying Pascal triangle. If we look, what is the Pascal triangle? Pascal triangle is basically you keep building a sequence of binomial coefficient. So if I'm doing, let's say n is equal to 5, so first I print 1, because any a raised to power 0, if we look at I only get 1, so there's one term, and so I get one coefficient. If I were to do a plus b raised to power 1, I get a plus b, and this factor is 1, this factor is 1, and it should display me 1, 1. If I were to do just guys 1 minute. A plus b square is a square plus 2ab plus b square, and we look at the factors. This is 1, this is 2, this is 1 again. So I should see next is 1, 2, 1. Similarly, if I were to do a plus b cube, this will give me 1a cube plus 3a square b plus 3ab square plus b cube. So my factors are 1, 3, 3, and 1. So next would give me, so if I keep building it up, that is what this is, Pascal triangle is what we get. So the job is to, given value n, so if n is 5, I should display this Pascal triangle like this. So if n is 5, I should display the Pascal triangle. If n is 4, I should display the first 4 terms. If n is 10, I should display accordingly. Now, given that you know looping, how would you like to go about building such a Pascal triangle? Any thoughts? Give a thought for 2 minutes and tell me how would you like to build this Pascal triangle. Let me display this again. Any thoughts, guys? How do you want to approach this problem? As I said, CS first is logically think how do you like to solve it. And once you're done logically, then it becomes much easier to put into the code. Don't start coding right away. Give a thought. How would you like to solve this? What is the pattern you see? So if my n is equal to 5, that is what I should be seeing. Any thoughts? How would you like to approach this problem? Who would like to answer? Hare Krishna. Arjun. Guys, you need to speak out. Punyasri. Are you guys there?
Yes, sir.
Give me a thought. How would you like to approach? Anybody? You have to start thinking.
We could try nested loops.
But yeah, but what would be the size of nested loop? So what is your thought process? If my input is 5, how many lines you need to put?
6 lines. The
6
6 lines of pattern.
Yeah, so that's the first thought process. So if you have input as 5, you need to print 6 lines. If input is 10, you need to print 11 lines. So that means you have to have a for loop which would run n plus 1 times. So either you run the loop from 1 to 6, or you can run this loop from 0 to 5. And since we are looking at the binomial coefficient, we prefer to run 0 to 5. So given that we know that we need to run this a for loop, because we need to display n plus 1 lines. Now once you are in a line, let's say I'm the line number 4. Or if I start with 0, let's say this is my line number 0, line number 1, 2, 3, 4, 5. Once I am at, let's say, line number 4, how many values I need to print?
5.
5. So if I am line number I, since I'm running my outer loop with I changing from 0, 1, 2, 3, 4, 5, some number, and this would be whatever input I given here. And so my first loop I'll be running, because I need to print n plus 1 lines. So I'll be running my loop from 0, 1, 2, 3 up to n. So I'll put a loop starting with a variable I, running from 0 to n. Now I am at certain value. Let's say I'm certain value of I here. Now if I'm certain value of I, how many values I need to print?
I plus 1.
How many?
I plus 1.
Repeat, please. I plus 1, precisely. So if I am at the line number I need to print I plus 1 values. Now if we look at, first value always happens to be 1. First value always happens to be 1. So I can just print 1 there, and then I can print only I values starting from next onwards. And can you find what these values are? If you look at these values, what are these values? If you look at, let's say this is 0, this is 1, 2, 3, 4. Now, given that I'm at I here, what is the relation between 4 and this 4 here? What is the relation between this and this, this and this? Or if I'm here, what is my relation between this and this, these values? So again, this corresponds to 0, 1, 2, 3, 4, 5. So if I'm at the line number I, how do I get these values? Any thoughts? Well, let's look at the line number 5. I'm at line number 5. What is the relation between 5 and these values? If the next line would be 6, value I'll be getting is 1, 6, 15, 20, 15, 6, and 1. So given that I'm 6th row, these are my values. Can you tell me how do we get these values? We just discussed them. What is the last example we discussed?
Factorial.
Not factorial.
Binomial coefficients.
Binomial coefficient. Can you relate? Is this a binomial coefficient? What is 6C1? What is 6C2? What is 6C3? What is
Yes.
6C1?
6.
6.
So if you look at these are all binomial coefficient. So, and whichever line I am in, all the values corresponds to all the binomial coefficients of that number. Are we clear here?
Yes, sir.
So that means if you look at my logical program, I should have one for loop which will run for I is equal to 0 to n, whatever n I have taken. My second for loop, which is inside, once I'm in I take a different variable. I know my first value is always 1, so I can always say print 1 here. I can say print 1. And then I can run my another loop for j is equal to 1 to n. Should be 1 to n or should it be something else? That's the question I'm asking you. The outer loop, this outer loop tells me the line number. Line number 0, line number 1, line number 2, line number 3, line number 4. And once I'm at the line number I need to print I plus 1 entries. I've already printed 1 entry. So how many more entry I need to print?
I.
So this second loop should run up to I and not anything else. And that is what programming is about. Programming is not coding. Program is, can you identify the struct, what is to be done, and then use that. Once you know, having done this, now I know my J vary from 1 to I. Now I need to basically find my binomial coefficient. And so I have the value of I indicate the line number, J indicates the respective entry. So for a given I and J, what does this value shows?
The binomial coefficient.
Of what? So this will be binomial of n comma I, n comma j, I comma j, or j comma I. What should my parameters be for binomial coefficient? Look, if I am
comma
the
j.
fifth row, yes, this should be I comma j, because I'm doing coefficient of phi c0, phi c1, phi c2, phi c3, phi c4, phi c5. Since NC0, if you recollect, NC0 is always 1. Hence, I'm printing the NC0. And then I'm running a loop 1 to n. And now I need to compute binomial coefficient of I comma j. This will be IC1, IC2, IC3, so on, so forth. And just now, previous example, we had discussed how to compute binomial coefficient. Now, using that logic, you can put the logic inside the for loop, and that will give us binomial coefficient. So let's look at the basic code segment. You need two loops, first loop for each line, second loop for entry in each line, which is the binomial coefficient, and compute that. So I start with that. So this is my first loop. If you look at, this is my second loop. Actually, I should only 1 to n and print 1 there before. So leave away this first part. I'll tell you why I'm doing that. So right now you can probably ignore at the moment. For the moment, you just ignore this part. I'll tell you why I'm doing that. So I compute the term, I print the first term as 1, which I am done, and I run my loop. This is for the each term of the binomial coefficient. And we know how do we compute binomial coefficient. Now you also look at, I'm doing little more efficiency there. Let's go back to Pascal triangle. If you look at this term, let's say look at this 10. This is obtained by, so what is my look at NCR and relation between NCR plus 1. So all I need to do is, so let's say, let me look at the first simple example. Let's take, I know what is my phi C2 is. It is 5 into 4 by 1 into 2. What is my phi C3? 5 into 4 into 3 by 1 into 2 into 3. So that means when I compute my next term, I can simply multiply both numerator and denominator by the respective terms, which is n minus r plus 1, and this is just r. So I take my previous term, multiply numerator, and divide by the denominator, one extra term, I'll get the next term. And that's precisely what I'm doing in my second loop, if you were to look at. So I'm multiplying the numerator extra term and denominator extra term, and that gives me the answer. Now, what I'm trying to do in this display, if you look at, I want output to appear as a triangle, just to make sure everything is available separately. So I should print that many spaces. So just to make visible, I'm printing that many space. So if you look at, because I'm putting the values on space, so each row I'm printing that many spaces. So first row I'm printing n spaces, second row n-1, third row n-2, and so on and so forth. That's what I'm doing so that it becomes properly formatted output. And that is what I'm doing in the code. As I said, hold on to the first part. So if you look at this part of the code, I'm just printing leading spaces. Whatever my I is, print that many spaces n-I, and then compute, and that basically gives me the program. And that is what primarily the Pascal triangle is. So if I were to run my Pascal triangle, I can run. Again, this program is given to you. It is an intense program line. You can look at it, run it yourself, make changes to it, play with it. Let's say 5, it will display the Pascal triangle of 5. If we give it 6, and so on and so forth, if we give it 7, we'll probably get the respective Pascal triangle. So we had discussed that, the examples as given in the book. Next class, I think we have a class tomorrow.
Oh, yes, sir.
Yeah, so we have class tomorrow. I think one is the timetable, and that means my timing would be 3rd hour class. So we'll discuss some more examples of taking a loop. So run it, practice yourself, so that you become clear, understanding, and I'm done. If any questions, please let me know, ask. Otherwise, we would disconnect.